Hi all. In this video, I will discuss LeetCode problem 995. Minimum number of k consecutive bit flips. You are given binary array nums and integer k. A k bit flip is choosing a subarray of length k from the nums and simultaneously changing every 0 in the subarray to 1 and every 1 to 0. Okay, so return the minimum number of k bit flip-flops required so that there is no 0 in the array. If it is not possible, then return -1. Okay, so we will be given an array like for this example like 0 1 and 0, and we will be given also k like here for this k is equal to 1. So we actually our target is first of all to make all 0 to 1. There should not be any 0 in the array. Okay, so what actually I can do to convert 0 to 1? So actually I have to take a k length subarray, and this will actually flip all the numbers like from 0 to 1 and 1 to 0. Got it? So for this example, like and also I have to find out that if it's not possible, then return -1, and it is possible, then I have to find out what is the minimum number of flips required. Okay, so for this example like 0 1 0, so I have to flip. Okay, I have to convert all 0 to 1. So first of all, k is equal to 1. So first of all I have seen 0 here. So our target is I have to make it 1. So I actually flip from this. So what is the length of the subarray? 1. So this will only flip to 1 1 and 0, right? So next is there any 0 still? Yeah, this is the position. There is still a 0. So if I flip this like 1 comma 1 comma 1, so this will actually flip this, and what is the final array? 1 comma 1 comma 1. So what is actually, it is actually polar 1. So our target is actually fulfilled. And what is the minimum number of flip required? Here actually 2. So answer should be 2 for this case. Like here actually it's 2. So I have to check any other combination also. Like for this, first of all our target is to flip this bit first. So 0 1 and 1. Then I tried to flip this bit. So what will be the array? 1 comma 1 comma 1. So here also we need 2 flips. So this actually final answer, minimum number of 2 flips we have required. So next example, let's see. 1 comma 1 comma 0, 1 comma 1 comma 0, k is equal to 2, right? So first of all, so if I actually I first seen 0 here, so I have to take k length subarray. So there is no subarray in right side, so I have to take actually left side only. Okay, so left side k is equal to means these 2. So what will be the array after that? 0 1 0 1. So and then this is 1 flip. Now if I have seen 1 0 again, so I have already flipped the right side. So let's take the left side actually. If I take the right side again, then it will be same previous. So it does not mean anything. So let's flip again, take these 2. So this is 0 1 1. So it's still actually we can't actually set, because there is no element in the left side, so we can't take any new subarray. So this is not possible to convert all 0 to 1. So here it should be, answer should be -1. Got it? Let's take the next example. 0 0 comma 0 comma 1 comma 0, then 1 comma 1 comma 0. And what is the k? K is equal to 3. Here k is equal to 3. So first of all, here actually I have seen 0 here. So first of all, take this subarray of 3 length and flip this. So what will be the array, resultant array? 1 comma 1 comma 1. This will be 1 0 1 1 0, right? Now here actually any 0 is present here. So take this subarray. So what will be the resultant after that? After flip, it will be 1 1 1 1. This will be 1. This will be 0. This will be 0, and this will be 0. Now take this subarray of length 3, or actually all are 0. So if I flip this 0, 1, 1, 1, 1, 1, 1, 1, right? So here actually we have successfully uh, followed the condition that all elements are 1 here. So how many flips are required? Here actually flip 1, here actually 2, here actually 3. So answer is 3. So I have to actually minimize this. Like we got that? Yeah, I can actually transform this array into an array, a resultant array such that all elements are 1. We found it. And now what is the next one is I have to minimize the number of flips. I have to check is there any combination possible or actually we need actually less than 3, like 1 or 2 by flip we can actually achieve this. Okay, let's check how. First of all, flip this 0. So what will be the array? This will be, so what will be the resultant array? 0, 0, 1, 0, then this will be 0, 0, and it will be 1, right? Now next is, suppose flip this subarray. So this will be actually 1, 1, 1, 1, right? Now I have seen this 3, 0. So what will be the resultant array? 1, 1, 1, 1, 1, 1, 1, 1. All are 1. So how many flips required? Here actually we need, we flip 1. This is actually 2. And this is actually 3. Here also it is 3. 3 flip required. So this is actually one observation that we can actually flip the subarray from left to right or right to left. Our answer is same. So order does not matter here. So we actually always get the minimum steps, right? So what is the brute force approach? Let's first discuss brute force approach. So first of all, we will be given an array this, like 0, 0, 0, then 1, 0, 1, 1, 0, and we will be given a 3 k length, right? So first of all, we will check, we'll traversing the this array, nums array. Whenever we say any 0, okay. So first of all, I have, this is actually 0. So I have to flip this. Anyway, I have to flip this because I have to actually achieve 1. So I have flipped. So after flip, what will be the subarray? Resultant subarray. From this to this 3 element will be flipped together. So I will actually from I. So for I is equal to 0, I less than actually n, I plus plus, and I will flip what? I will flip for j is equal to I, j less than I plus k, j plus plus. This will be actually all will be flipped, like nums of j will be inversion of nums of j, right? 0 will be 1, 1 will be 0. So after this one flip, what will be the resultant array? 1, 1, 1, 1, 0, 1, 1, 0, right? Now I am again traversing. This is a 1, no problem. This is 1, no problem. I do not have to do any flip. Here also 1. Here actually I got 0. So what I have to flip this 3. So I will actually just call the, I will just traverse the array from here to here, k length, and flip the value. So what will be the value? 1, 1, 1. This will be 1, 0, 0, and 0. Now again I have got go to the next index. So this is 0. So I have to again flip all this. So for each index, if it is all matched, like 1, 0, 1, 0, 1, 0, 1, 0, then what will happen? I have to call every time flip every index, every alternative index, or every index, because it will be actually flipped. So I will actually, what will happen that our for each index I will call k type. I will traverse the array k times. So for n, I am calling this subarray k length k every time. So what is the time set of this? N into k, right? So what is the constant for n and k? N and k both are length can be same. So n length is 10 to the power 5 and k also 10 to the 5. So what will happen? Time set will be n square. So 10 to the power 10, it will give us TLE. So is there any optimal approach? Yes. How actually it's possible? Like for this, suppose 1, 0, 1, 0, 1, 0, and suppose k is equal to 2. So whenever actually I am here actually 1, I don't have to flip. Here actually 0. So how much actually this flip actually effect? What is the length from this to k length? From this, these two these two element will be affected ultimately. So I will actually set that where actually my effective will be end, like here. So suppose here actually length actually k is equal to 3, then it will be better. Okay, length k is equal to 3, subarray length is 3. So this array will be 1 0 1 0 1 0. Okay, so this first time how actually I called flip here. So these three element will be got affected, right? Now what is the ultimate, what will be actually the ultimate value now for this? This will be 0 and this will be 1 and this will be similar, right? This is actually the after flip of this. So whenever I come to this next index, what will happen? I have to check, okay, this is not actually 1. What is the actual value? Because this is got affected by the previous index, flipping of the previous index. So what will the ultimate value? 0. So they can, then what I have to do? I have to again call the flip because this is ultimately 0. So I will again call. So what will be the effective then? This subarray will be again affected. So ultimately what value will change? This will be again 1. This will be again 0. This will be 0. This will be 0. So whenever I go to the next index what? This is again okay. Ultimately this is 0 previously, but ultimate value also this is 0, because what will happen? 0 first of all I flip for this index, so it got 1, and again this is got affected for this 0. So this ultimately go to 0. So whenever actually I go any even number of times flip, then ultimately both will be same. X will be x. If it is odd time, then what will happen? X will be inversion of x. Like if it is 0, then it will be 1. If it is 1, then it will be 0. You can check actually. Like for 0, if I only flips only once, then what will happen? It will be 1. If I twice, then it will be 0 again. If I thrice, then what will happen? Again 0. Got it? And similarly for 1 also. If I call flips only once, then it will be 0. Twice, then it will be again 1. If it is again I call, it will be again 0. So thrice, every odd number, it is the value will be got inversion, right? So I have to count how many flips are currently effective for this. Like here actually 1 0 1 0 1 0, k is equal to 3. So first of all, this actually will be flipped. So what will be the array? Ultimate array. We will not actually update the array. We are just check how many actually flip are getting affected. So this will be actually 1. This will be 0. This will be 1. This will be 1. This is 0. Right. Now I know how many actually flip here effective. Only 1. So this will be actually what will you prove? This will prove that our value will be got inverted. So whenever I go to the next index, okay, this is actually currently in the ultimate actually array. This is 1. So how many times it is got effective flipped once? So what will happen? Ultimate value is module of 1 inversion of 1. It will be 0. So 0 means what? Again I have to call the flip. So I will call the flip. So currently flip will be 2. Right? So what array actually subarray will be get affected? This, right? So this will be actually affected. Now go to the next index, what? 0. And how many flips actually effective? 2. So ultimately if I what actually set the observation that if I flip twice or any even number of times, then it will be actually actual value. So here it is twice, so ultimate value is 0 also. So again I have to call the flip. So what will happen? This will actually affect this, right? Now come to this. So how many flip will be currently here? How many flip will be there here? It is 3 updated because again this is called here. So that's why I forgot to update. So this will be ultimately 3. Now whenever I come to this index, So is there any Savere got out of bound? Yes, this Savere got out of bound, right? So how many flip will be effective here? Actually, two, because this Savere got end here. So this will ultimately, you can actually check, like for this actually we call once, for this, right, and for this also we call it once, like for this. So this one actually got affected twice, right? So actually what is the value? Ultimate value, flip value is 2. So ultimate value will be the same as the nums array value is 1. So ultimate value will be also 1. Then I don't have to do anything. Then go to the next index, 0. Is there any Savary got out of bound? Yes, this red color, right? This got entered in the last index, previous index. So how many flip will be here actually currently? 1. So what is actually ultimate value after effective from the previous flip? So 0 is the current value, and how many flips actually it got called? 1. So what is the inversion value? It will be 1. So I do not have to do anything. So it's got ended here, and all are got 0, 1, right? Got it? Let's go to the code actually. Okay. So this actually I have to find out how many flips actually I have called and how many flips effectively current I have. Because somehow it will be in between if Savere it got out of bound, then I have to actually decrease the effective flip also, right? Now, and also I have taken one vector. Actually, it's actually help us to find out what is the index it's got. Actually, one Savere will got out of bound. Okay, initially all index will be false, and it will set whenever actually, like on which index one Savere will be got out of bound. I will set it as true. Okay, so I'm traversing the nums array. Okay, so I'm checking if the current index, is there any Savere got out of bound at the current index. Any I means I minus k was flipped. Starting index is I minus k. So current index I will be out of bound. So that's why I will just decrease the flips count. Okay, just adjust the flips. Means how many actually effectively it will got affected, the current element. Now I will check what is the ultimate value in the current nums. Okay, I'll check like what is the flips. Number of flips means 1. Like suppose odd, then what will happen? 1 is equal to 1. Then I have to actually flip. Why I have to flip? Because like current element value is in the nums array is 1. Now I am calling thrice, suppose. So what will happen? 0, then it will be again 1, then it will be again 0. So it's got actually changed to 0. Our target should be 1. Then that's why I actually any odd times with 1, I have to actually call the flip function, and any even numbers like for 0, if I call it even times, 0 1 again 0, again 1 again 0. So this is even times. This is here 1 2 3 4 times I have called. So in even times it's get again called 0 ultimate. So whenever any even value, then and the current value is even, you got right. Even number of flips is equal to even value. Then I have to call flips, because this will give us the 0 is equal to 0, ultimately the same value. And if it is odd value, then I need actually even times flips. Then what will happen? If it is a I transform even times flips even times, then what will happen? I actually get 1 again. But if it is flipped odd times, then what will happen? I got 0. That time actually I have to call the flips again for particular to flip the particular index number. So I will check if it is both odd or even. Got the logic? Why actually I'm doing this? That time I have to call the flips again. So I will actually number of effective of flips will be got increased, and also I have increased the answer. Answer means how many flip I actually called. Now I am checking if the Savere length is out of the num size. Then I can't actually take this subarray of subarray of k length, or actually I can actually call the flip. So that time actually I have to return -1. Else what will happen? I will just set that I plus k index one subarray effective will be ended, right? That's why I at the index as I plus k I will actually set true at the, and whenever we go to the data index, like it is 0, then k is equal to suppose 3. Then what I am storing 0 plus 3 at index 3 I will actually store as true. So actually how many, which element will be got affected actually 0 1 2, and at the index 3 whenever we come here I will adjust that. Okay, one subarray got ended at the last index, previous index. Got it? Actually, how actually I am store I plus k, and at the end return answer. Got it? So what is the time velocity of this? Time velocity here actually we are just only traversing the nums array only once. Got it? And what is the space complexity? I have taken one extra array vector, or actually I am storing on which location our one subarray if call effective will be ended. So again the time slot will be big of n. So here actually I am storing at I plus k, right? Here actually what I am doing, I am whenever I am flipping, calling the flip function at index I am at index I. What I am storing at I plus k, I am storing that that one subarray will be end here. True, right? I plus k. So it is both similar that whenever I can actually store on the I also. That how actually then what will the logic changed whenever we're checking the average ended or not. I will check that I minus k is true or not. Got it? I minus k, because I minus k will be set here. So I'll check whenever like from 0 1 2 3. So from 0 to 2 actually I have called this flip function k is equal to 3. So what will happen? I will come whenever I will come to the index 3, 3 minus 3, check element will 0. 0 is called actually the flip function. So this will be true. This will actually got end effected here actually. So that time actually I will decrease the flip. Okay. So let's see the code. Actually I can optimize the space in this way like here. So current flips actually 0 and total flips this will actually answer. Got it? And now similarly I'm traversing the nums array similar way. Then check that whenever I greater than equals to k, then actually I have a probability that I have a called any flip function or not, and I'm checking that is the I minus k is equal to 2 or not. 2 means I can actually do anything except 0 and 1, because 0 and 1 is the input array. I have actually, instead of using the another new vector, I actually modified the input vector with 2. 2 means I actually flipped call the flip function from the particular index. Okay, so I will just call, I will check that I minus k index value is 2. 2 means what? I actually called this flip function particularly starting from the index I minus k, and it will be got ended at the index I minus 1, right? At the previous index. So this will actually decrease the current flips number of effective flips here. So I'll check similar actually I will check that how many actually like odd with odd or even with even. Then I have to flip the call the function. Then I will check if I plus k, if similar if it is the subarray, we can't take any subarray of length k which is actually out of bound. Out of bound means there is k limits are not present. That time actually whatever I have to return -1, and else what I have to do? I have to just set this that yes I have called a flip function k array k subarray flip function starting from index I. How actually identify that? I will set this as 2. Okay, and total flips will be increased by 1 because I have calling flip function 1, and current flips will be increased because I have called a flip function new flip function, and similarly in the end return the total flips we called. So what the time velocity? Time velocity will be similar because I am traversing the nums array again. So time is big of n. But what is the space complexity? We are not using any new vector. In this previous approach, I actually used this find flipped ended vector. But here actually there is no such vector. We use this nums vector instead of this. So time space complexity will be big of 1. Got it? I got the logic also, right? Thank you.